Hi everyone, welcome you all to Deep Matrix. So right now we are in the Kubeflow series and we have two videos that has been recorded and posted before. One is on how to install Kubeflow in Minikube. Like this is an initial setup for Kubeflow servers, and like once the server has been set up, like in the second video we have seen like how to create a basic pipeline. So like we were looking into this addition and subtraction function, but like today we will be looking into how to create a actual Kubeflow pipeline. So we know like Kubeflow is predominantly used for ML workflows. So let's try to create one of the workflows in the Jupyter notebook, and we'll try to push it into Kubeflow, and we'll see how to execute it. So in order to proceed further, like just make sure you have your Kubeflow pipelines running in your local, and like your Docker is up and running, and also like I have have keep my servers running in the different terminals. So let's go to Jupyter notebook. So this was the code that we were looking in the last video. So let's try to build a new server. Okay, so let me import kfp, import kfp dot components, import dsl. So I have a Kubeflow server. Okay, so these are my imports. One is I'm importing the kfp unnamed tuple. So compiler, like we are going to compile the workflow, and dsl is to create different dsl components. One is pipeline and another is component. So let me execute. Okay, it's done. So now let's just create a dsl component first. So at dsl dot component, we'll do only pre-process. So pre-process has been defined, like I'm going to give it as named tuple. The reason why we are defining this typing is sometimes when you execute a workflow, you try to pass the output of one workflow to the another workflow's input. So something like this. In the last one we have seen A, B, but in order to get the output from the first task, like we just did first add task dot output. Let's say instead of having one output, you have multiple outputs. So in that case, like you need to define this. So it is called outputs, and after that we pass a list. So let me copy this. So in this case, my outputs are going to be xtrain, xtest, ytrain, and ytest, which means in the pre-processing, I'm just going to get my output as 4 different datas. One is for training and testing. In that, we are going to have features and target. So that's it, and like let's move to the first part. Import subprocess. So now subprocess dot run. So I'm going to do pip install scikit-learn. Let me check the syntax. Check equal to true. So yeah, let me complete the code, and after that I'll explain what is exactly happening here. So let me load the iris dataset and train test it. So we're just importing both the imports, because instead of I'm loading it as file, I'm going to get the file or like the data from the sklearn.datasets. So after importing, now we can do train test split. So it's like xtrain, no, train, xtest, ytest equal to train test split. Train size equal to 0.8. Okay, iris.data and iris.target. Okay. So I just saved load iris into iris variable. So now iris dot features will be my train features. Iris dot target will be my target. So yeah, iris dot data, iris dot target. Sorry, not features, data. So now while returning, we are gonna return it as list, because in the named tuple, when we defined the outputs, we have given it as list. Let's say I'm giving it as dictionary, then it has to be to dict or something. Okay, so it's purely based on what data type that we define in the named tuple. Sometimes, like, returning the outputs which are of different data types at the time of definition will cause an issue. So let me explain now what exactly happening. Before that, one last thing. So base image equal to Python 3.9 slim. So with that, like, this workflow is done. We just created one component. So in the last video, we have seen basic addition subtraction function, right? So one advantage of this function is it's a basic computation, and we don't need any other packages to be installed at the time of execution. But the current component that we created, if you notice, we are using Python here. Even in the Python, we are using a package sklearn most. So what basically happens if I don't declare this base image, if I just create a component with the function only, and directly if I try to execute these two lines, it will fail, because first thing, we did not tell this a particular workflow that what to use as a base. So in this case, for this whole execution, we need this Python as a base. Correct? So that's why Python 3.9 slim. It's a 3.9 version. Slim is like a minimum executable packages that are needed in Python in order to run some basic function. So it's not like it will install fully, but it will have a basic pip3 and everything. So that's why I have declared a base image. Now, in order to run sklearn functions, I need my scikit-learn to be installed within the Python, correct? So that's why we include this subprocess. In subprocess, we are installing the scikit-learn package. So it will make sure scikit-learn is installed within this image. Now when I try to run this imports and try to run this attributes, it will work, because it ensures that a package is getting installed in the base version of Python, and then that will be used in the whole execution. Then these steps you already know. We are just train test split, and we are just returning it. So a basic component is ready. Okay, from sklearn, what is the issue? Okay, indentation problem. Okay, got it. So I just have to move all the lines to one spacing. Okay. So a component is created. Now next thing is pipeline. DSL dot pipeline. So again, in the pipeline, I can directly call this iris pipeline. So let's call it demo3 pipeline. Demo3 pipeline. And in the step 1, I'm going to call my component, which is just preprocess. So I'm just calling it. So there are few attributes that we need to pass, so that you can okay, like, see using shift plus tab. So first is function. Okay, so name equal to demo3 pipeline, and descriptions are not needed, like that, not necessary. That's it. So we just created a pipeline. It's a basic one. We'll see how to add another steps going forward. So now, as I said before, we have a compiler like that has been imported. So let's compile dot compiler.compile pipeline equal to, so I'm going to give my actual pipeline name, which is called demo pipeline, and package path. So last time, if you notice, we didn't do this step because we just used this, create run from pipeline func. But this time we are going to compile it first. So demo 3. So let me compile and we'll see what error we get, or like whether it executes properly. Okay, it got an unexpected keyword. Okay, pipeline function. Okay. Okay, maybe syntax issue. So it has been compiled, but nothing happened. So now we can go and check in the home folder. You can see a demo3 pipeline.yaml has been created 5 seconds ago, which is exactly the file name that I have given for package path. Let's take a look what it is here. So this is basically create a YAML file for our pipeline execution, and it will create a deployment spec. So now when I take this pipeline and run it in KFP, this file get executed and it will run, all my code. So you can see my, Python scripts as well and everything. So this is how it works. So we just compiled it so that we could create a sample pipeline. Okay. So let's go to Kubeflow and go to pipelines. See, even in the before video, what we saw was just an one-time execution, correct? So because if you see, like, when we ran this addition subtraction in the pipeline section, we don't see anything. In the runs and experiment session, we could able to find that execution, correct? Which means, so it's more like a run what we did in the last video. So this video is more about a reproducible pipeline or re-executable pipeline. So just go to pipeline, upload pipeline. So okay, let's not do it this way. Instead, like, I have a code ready, we can directly upload it. So now let's try to connect to the server, which remains the same. Okay, let me just copy. So we are just connecting to the KFP client in a local server. So it's been connected. So now client dot, okay, upload pipeline. So pipeline name equal to demo3 pipeline. Pipeline package path. So pipeline package path equal to this demo3 pipeline.yaml, because it's in the same directory. So do I need any other stuff? Yeah, that's it. So let's try to upload pipeline. So it has been uploaded. Now let's go to pipeline section and we can see demo3 pipeline has been updated. But as of now, you won't see any execution is happening because we just uploaded the pipeline. Now we have to execute it. So just contain pre-process and you can see the output parameters, what is the image we're going to use, and commands and everything. So let's try to create a run. So let's keep it 1 off so that like it will execute only once. So now we can come to experiment and you can see a run is happening. Let's wait for 1-2 minutes. So yeah, it started. So it is still executing. And also going forward, like, we will see components that will use basic Python image. So it's not like, we just execute very basic functionalities. Instead, we will try to see what are the important steps that are found in MLOps and ML that could be, utilized properly. So yeah, it got succeeded. Let's see the output. See, if you can see in the input output, like we saw the output parameters, and if you notice here, like we have given list, correct? So we have given 4 lists. So in the output, you could see 4 list of parameters with the same name that we defined in the named tuple. So this is how this named tuple and typing functionalities work. And you can see task details, when it ran and everything. And in the logs, you could see, like if you have any print statements, like that can be printed here. So basically it will capture all the logs, like how it is executing, what are the lines are getting executed, and what is the output that we are returning. So this is how clearly Kubeflow will give you details for each and every particular line. And also I would suggest, like if you are trying to explore MLOps, I would suggest better start with Kubeflow, because instead of paying money to all the cloud platforms to utilize their MLOps workbench, you can start off with something which is free of cost. And here you get a more degree of flexibility in terms of changing and pushing your custom stuff. So like this makes sure, like if you learn it, you will understand the basic crux of Kubeflow. So that's it about, like this video. We did pre-processing. Now let's try to add more and more steps in the same Kubeflow pipeline. So in the next one, we will see how to do training and how we can upload artifacts to bucket or something. So that will help you understand the workflow one after the other. I hope you all like this video. Meet you in the next one. Until then, enjoy learning. Thank you.